Welcome back to the Fundamentals of Electronics lecture, dear students. In last lecture, we have discussed about the classification of regulator, Zener diode as a shunt regulator. I hope you got all the concept regarding that. If you have any query about that, then you can add a comment. Okay, let us start the today's lecture, that is lecture number 3 on chapter number 5. Today's content are 3-terminal fixed positive voltage regulator by using IC 78XX and 3-terminal fixed negative voltage regulator by using IC 79XX. First of all, study the pin configuration of IC 78XX. As shown in figure, you can see the IC 78XX has 3 terminals. Pin number 1 is nothing but the input pin. Pin number 2 is ground pin. Pin number 3 is output pin. Here 7-8 digit represent fixed positive and XX digit represent voltage amount, means the voltage which we are getting at the output of IC that represented by digit XX. Instead of 78XX, if there is a 7805, it means that regulator provide us fixed positive 5 volt at the output pin of regulator, because last 2 digit on the place of XX represent output voltage provided by the particular regulator. Similarly, if there is a IC 7812, then it will provide us fixed positive 12 volt at the output pin of regulator, and so on. These ICs are available with several output voltages such as 5 volt, 6 volt, 8 volt, 12 volt, 18 volt and 24 volt. IC 78XX can provide maximum 1 ampere current at the output. This ICs has internal thermal shutdown and short circuit current limiting. One point should be noted down here. You can apply maximum input voltage up to 35 volt, but at minimum side you can apply Vout plus 2 volt input voltage. Minimum side input voltage amount can be vary up to Vout plus 2.5 volt. For your knowledge purpose, you should know the metallic part at the top of the regulator IC is used to fit the heatsink. Now let us discuss the application of 78XX series. From the series, I have chosen IC 7805 and I have designed a circuit diagram for fixed positive regulated power supply using 7805. As we know, to design every regulated power supply, we need AC input voltage, that is 230 volt 50 Hz, that I have applied at the primary of step down transformer, and at the output of secondary we will get reduced in amplitude voltage, that is step down voltage. Suppose I consider my step down voltage is 12 volt AC. This step down AC voltage is applied to the rectifier as a input. Instead of using half wave rectifier, we are using here full wave rectifier, and in full wave rectifier we are using bridge full wave rectifier. Instead of bridge full wave rectifier, you can use center tap full wave rectifier or half wave rectifier, but we need more accuracy and more stable outputs. That's why we will prefer bridge full wave rectifier over here. Then the output of bridge full wave rectifier is applied to the filter. There are various types of filter. Out of that, we have used simple and cheapest filter, that is nothing but the capacitor filter. C1 is nothing but our filter capacitor. Again, instead of using capacitor filter, you can choose inductor filter or LC filter or pi filter. But due to inductor, the weight of your power supply will increases. And in pi filter, there is a three components, two capacitor and one inductor. And so that the cost of your power supply will increases. It means choosing a rectifier circuit or filter circuits is totally depends on you, your application and your budget. Then the output of filter capacitor is given to the capacitor C2. C2 can be ceramic or tantalum capacitor. It is used when our regulator is located far away from the filter capacitor. It means to connect the C2 capacitor in circuit is optional, but it should be connected for circuit safety. Capacitor C2 filter out the effect of stray inductance of wire. Stray inductance is nothing but the unexpected and unwanted inductance of wire. Here I have chosen C2 as a ceramic capacitor. That's why there is a no polarity to C2 because ceramic capacitor is non-polarized capacitor. Then the output from the C2 is given to the input pin of 7805. As we know, pin number 1 is the input pin. That's why as shown in figure, the output of C2 is applied to the pin number 1. Also we know that pin number 2 is ground. That's why the 7805's pin number 2 is connected to the ground. And as we know, pin number 3 is the output pin. That's why we have taken output from the pin number 3. Then that pin number 3 is connected to the capacitor C3. Here I have chosen capacitor C1 and C3 are electrolytic capacitor, and electrolytic capacitors are always polarized capacitor. That's why I have shown polarity to the capacitor C1 and C3. C3 is nothing but the Cout because which is connected and near to the output terminal of IC, and C2 is also called as Cin because which is connected to the input pin of IC. Cout, that is C3, is used to improve the transient response of regulator. Transient response is nothing but the response of regulator to the suddenly load fluctuations. It should be always better because if there is a load variation, still we get the constant DC output. Finally, the common point of pin number 3, that is output pin of 7805 and C3, is connected to the load, that is RL. Here I have chosen load as a resistive load. In practical life, there will be a LED or any electronics device. You can see across the load resistor we got output voltage which is fixed positive 5 volt. In this way, our regulated power supply works with IC 7805. One point should be noted down here. The values of C1, C2 and C3 are depends on application and designer. I hope you all are getting me. So, shall we go ahead? Okay, let us discuss about the fixed negative regulator, that is IC 79XX. IC 79XX is the complement to the 78XX series. Again, here 79 represent fixed negative and XX represent amount of output voltage provided by the regulator. This is also 3-terminal regulator IC. Pin number 1 is the ground pin, pin number 2 is the input pin, and pin number 3 is the output pin. This regulator IC is available with several output voltages such as 2 volt, 5 volt, 6 volt, 8 volt, 12 volt, 18 volt and 24 volt. IC79XX series can supply maximum 1.5 ampere output current. It also has internal thermal shutdown and short circuit current limiting. Instead of 79XX, if there is a 7905, then it will provide us fixed negative 5 volt at the output of regulator. Because the digit at the place of X represent the output voltage provided by the regulator IC. Similarly, if we have a IC 7912, it will provide us fixed negative 12 volt at the output pin of regulator, and so on. For your knowledge purpose, you should know the metallic part at the top of the regulator IC is used to fit the heatsink. Now let us discuss the application of 79XX, that is fixed negative regulated power supply using 7905. Figure shows the circuit diagram for respective topic. As we know, to design every regulated power supply, we need AC input voltage, that is 230 volt 50 Hz, that I have applied at the primary of step down transformer, and at the output of secondary we will get reduced in amplitude voltage, that is step down voltage. Suppose I consider my step down voltage is 12 volt AC. This step down AC voltage is applied to the rectifier as a input. Instead of using half wave rectifier, we are using here full wave rectifier, and in full wave rectifier we are using bridge full wave rectifier. Instead of bridge full wave rectifier, you can use center tap full wave rectifier or half wave rectifier, but we need more accuracy and more stable outputs. That's why we will prefer bridge full wave rectifier. You can observe one thing over here, that the polarity of bridge full wave rectifier diode is reverse as compared to the positive regulated power supply using 7805. Because now we have to design a negative regulated power supply, so that during the negative half cycle our diode D1 should get forward bias. It means if negative half cycle is present at the secondary of transformer, then point A becomes negative and point B becomes positive. That's why diode D1 is forward bias and D3 is forward bias. Whereas if positive half cycle is present at the secondary of transformer, then point A is positive and point B is negative. Because of that, diode D4 and D2 will be forward biased. Hence, we will get negative voltage at point C with respect to point D. Then the output of bridge full wave rectifier is applied to the filter. There are various types of filter. Out of that, we have used simple and cheapest filter, that is nothing but the capacitor filter. C1 is nothing but our filter capacitor. Here you can observe one thing, that the polarity of capacitor C1 is reversed as compared to the positive regulated power supply, because we know that at point C we have available voltage is negative. That's why we have connected negative terminal of capacitor C1 to the point C. As shown in the figure, output from the C1 is given to the capacitor C2. We all are aware about the function of C2 that I have explained in the positive regulated power supply. Again, the output from the C2 is applied to the input pin of negative regulator IC, and here the input pin of negative regulator is pin number 2. That's why the output from the capacitor C2 is given or applied to the pin number 2 of 7905. Also, we know that pin number 1 is the ground pin of 79XX series ICs. That's why the pin number 1 of 7905, that is negative regulator, is connected to the ground. And pin number 3 is the output pin. That's why the output is taken from the pin number 3 of 7905. Here it should be noted that the input to the 7905 is negative voltage and the output of the 7905 is also negative voltage. That's why the output pin of 7905 is connected to the negative terminal of capacitor C3. C3 is nothing but the Cout, because which is connected and near to the output terminal of IC, and C2 is also called as Cin because which is connected to the input pin of IC. Cout, that is C3, is used to improve the transient response of regulator. As we know that C1 and C3 are the electrolytic capacitors and they are polarized. Out of that, their positive terminal is connected to the ground, because now we are discussing about the negative regulated power supply. Whereas capacitor C2 is the ceramic capacitor, which is non-polarized capacitor. That's why there is no need to indicate any polarity to the capacitor C2. Output from the pin number 3 and negative terminal of capacitor C3 is applied to the load resistor RL as shown in figure. In this way, we got fixed negative 5 volt DC output voltage across the load resistor. Instead of load resistor, you can use any electronics device or LED. This is all about the 3-terminal fixed regulator ICs. So let us stop here today. We will go ahead in next lecture. Thank you for watching and listening the video.